Hello, everybody, and welcome to today's device management interface brigade call. Thanks for joining as usual, and the call is public and recorded, so please be mindful of whatever comments and information you share with the team. Today we have a pretty good number of items for the agenda that I want to touch before we go and have a final end to the year and have a final release before the end of the year. So the first one is regarding startup configuration. We merged this patch, which included all the elements needed to have an initial startup configuration loaded into the device. We decided that there should have been an option to retrieve the configuration. Amit, any update on this one?
Thanks, Andrea. So whatever internal discussion we have had on this, so right now the thought is that we should have an API or to retrieve the version of the configuration. So basically some information through which the configuration that is running on the system can be identified, but we don't really need to retrieve the configuration per se. So the thought is
why not the whole configuration?
So because when we are passing the configuration itself, we are just passing an URL, right, where the configuration is. So yeah, and if you were to retrieve it, it has to come back as a blob, which does not really have too much of a meaning.
What happens if the URL
right?
doesn't exist anymore? Right? The URL was temporary when you brought up the interface for the configuration, and then it's no longer there.
Yeah.
Right? You can't get the configuration.
So the configuration would be there in the device, right? But what we are saying is we just need, having an identifier of what the configuration is being used in the device should suffice for the northbound systems, because northbound systems know what configuration was pushed to the device, right? So
what I'm suggesting though is that northbound system lost that file. That file's gone away. It's temporary. I can't go back and get that file anymore. So giving me the URL doesn't help me because the URL doesn't exist anymore.
Yeah. So what we are saying is that instead of returning back the URL, we just return or the device just returns back a version of the configuration. It could be a semver version, a string, which just says, okay, this is the version of the configuration. Startup.
I understand, but I can't get that. That doesn't help me necessarily.
So I guess
because I don't have the data anymore. So how would I get?
So I guess there's two elements to this. One is that first of all, I would return both the URL and the version. So that's just myself returning two things: the URL and the version. And the other one, to your point, David, is really who holds the truth and who is expecting to have that information. If we say that the device is our source of truth, then I would agree with you that we would need to return the whole configuration. But if we say that the northbound systems that are present within the complete solution are the ones that hold the complete truth, meaning that we always expect them to have that initial configuration somewhere, and that they can, maybe not through the URL because that URL was temporary, but maybe through the version they can retrieve it, then we don't need it to return we don't need to return the whole thing. That is up for debate. I don't know which one is the right one. If the device
I agree with what you said, but I think the device is always the source of truth.
Amit, you think?
Yeah, so if that is the case, then the only choice that we would have is to return the complete configuration as a blob through the interface.
Byte stream? No, what would be that blob? Because the other issue I see in returning the whole configuration, just to lay out everything I'm thinking, is that it might not be, there might not be somebody that interprets it.
So this is similar to software, right? So for example, you just ask the device, okay, what's the version of the software that you're running? Similar to that, you just ask the device, okay, what's the version of the startup config that you're running?
But when I get released software, and I get a simver with it, the assumption is that will never change. Right? That is static. That's not always true in software. It's not always true in device configuration. And when you look at any hardware today, you typically have the startup. I'll use a vector. No, you have a startup and you have a running configuration. Sometimes you have kind of the next configuration. When you're dealing with devices, you typically always ask them what their configuration is, because the assumption is that the source of that configuration isn't something as locked typically as a software release version. And that many people are operating this within an organization, and that things could be changed without necessarily a simver changing. Unless you're going to do something like a DevOps operation where you say, look, what we're doing is the configurations in a Git repo, and that simver is not a simver, it's a commit, which is essentially immutable. And so you have something of that nature. Then I might say, okay, look, if it's you still have the option, potential to lose it. But if we're going to say our mode of operation is the configurations in a Git repo and the version is a commit, well, okay, if you mess up your Git repo, that's a different issue. But I don't think we're saying that, because I think we're saying just right now it's just a generic URL, and there's no control around what's at the other end of that URL.
Yep. I mean, I'm fine returning the startup configuration. The other question that might be worth asking is if devices do support this returning of the initial configuration. We could put the API in, but if there is effectively no way where the devices can actually return this initial configuration because it got modified or things like that, I'm not even sure we want that. So, to be honest, I would like to hear somebody that has device-related experience.
Yeah, for example, I would get into bigger trouble if I would have to return that configuration. This would require to do changes to our device, because currently it's not possible to return it in exactly the same way. And I also expect that if you have a device, for example, which is actually, so where you're actually only passing the URL to the device, and the device is then downloading the configuration from somewhere, I wouldn't expect that this device supports to return you the file again. I mean, it might, but currently for our device, it's not possible. So, I mean, we would have to store the configuration in the device manager.
Which is really not the point.
Yeah, and I would also expect that the truth is always north of the device and not in the device.
But even when we look at ONUs today, right, and OLTs, we typically invoke a stomp on their configuration because we don't sync back from the device what's there. So the reality is the device is the device. It's the source of truth. It knows what it has.
But the startup configuration, is that something that's pre-programmed, or or that's basically a program file that goes and grabs on startup, or is this something that's pre-configured in the factory and sent out with the device? Is this startup
No,
config
this is something.
is dynamic?
This is something that gets. It's dynamic. Yeah, it gets fetched.
Okay, this is like a zero-touch provisioning.
Could be, yeah,
file
one
or
of the
something,
use cases. Yes, one of the use cases.
I mean, for our device, the startup config is actually something we put on the device in the factory. And we are then afterwards, you would only have to update it if it's needed.
Yeah, so presumably that would be like a file name and a version or something, or
yeah. For our device, it's not a file name. We have a netconf. We're using netconf, so there are no files. That's why.
Is it version controlled, or I assume if it's factory configured, there must be some kind of, but it must be some
Yeah,
kind of
there will be a version. So we will store a version for the startup configuration, and you can query the version afterwards. And this is what we.
Yeah. Wouldn't that tell you everything you need to know? Or?
I think
so there is a distinction between, it's deployed kind of burned into a chip, if you will, at the factory versus downloaded dynamically. Do we have both use cases, or is it just always burned at the factory?
Well, I think there's probably both cases, I would assume. I mean, it's usually programmed at the factory, right? If it's a startup configuration that needs to be executed to actually maybe communicate with the management system.
Yeah, I guess my experience with switches and routers is, you can reset, you can configure what the startup configuration is dynamically. It's not something it's not firmware. And it usually is changed by pushing a file or pushing command changes and then saying, yep, and that's my startup config.
Yeah, so if you just return the file name and a version, and the file name may be null or something, I mean, there's always a version maybe.
Again, if I push changes, up down interfaces, put IPs on a router interface, whatever, and then say set startup config, there's no version there, there's no file name there. You're kind of saying take the current state, if you will, of the device and make that the startup config. Which is very different than saying I'm going to burn a startup config at the factory.
Yeah. That's different from, this is by running config and I save it as my startup config, right? And that's what we're talking about here, I think is different, right? I mean, because the startup config could be just, I can just dynamically change that anytime I feel like, right?
Yep.
But there was pre-programmed into the system to bring it up is either, it's a factory configured thing that has presumably some kind of version of maybe a file name, I don't know.
But again, are we talking only that use case? It's burned at the factory. Or are we talking I can modify the startup config? Because you reference the URL when you load the startup config, which essentially says to me it can change. It's not something that's burned at the factory.
I think in our case, it's both. So we will provision something in the factory, but you can update it later on. So what we're doing in the factory is
as well.
Yeah. So what we're doing in the factory is mainly to allow the zero-touch provisioning later on. But in addition, it might be needed that you will have to update this because you have new requirements or whatever. And that's why we needed the device manager as well.
And the problem is if we rely on the external systems to maintain the SIMVer and guarantee that every time that this config changes, there's a SIMVer change, it's a risk, right? Because I can no longer go to the device and authoritatively say what's on the device if that SIMVer isn't strongly controlled. And as you indicated earlier, that the source of truth, that strongly controlled source of truth, is outside the device. If that's not strongly controlled, all bets are off what's on the device.
Okay. So to be honest, I don't want to
Again,
put myself.
if there's no use case, if people want to go the other, go the way that, okay, we're going to assume strongly controlled source of truth, SymVerd's off the device, so be it. It's a risk.
So what I would do is I would go that way for now, in the sense that there's nothing preventing us in augmenting the API with the full blob if we see that that is needed. So what I would do, Amit, is I would start with the URL and the version within this API. And if we see that this gets out of hand and we need the version and we need the full configuration too, we just add the full configuration. Would that work?
I think that sounds fine, yeah. I think we can start with something of this sort, and I think, yeah, as we gain more experience, I think, yeah, we come across more use cases, definitely we could enhance the interface. Yeah.
Yeah. But then again, I mean, for our OLT would mean that the URL is not stored on the OLT, but it's stored within the device manager only.
Fine, but I think the URL needs to be there.
Yeah.
So what's the URL when the config's burned at the factory?
There is no.
I guess not.
In this case, we have to return an empty URL. So the only thing you can rely on is a version number. If you do not mess it up, as you said, there is a risk that.
So if the only thing we can rely on is a version number, what's the value of returning the URL at any time?
In theory, if the URL is there, you could go and fetch it from there. If it's not, you kind of have to know the URL a priori, or you kind of have to know what it is a priori. It's just you could put it as optional if you want.
Right, but there's ambiguity there, right? If there's no URL, all we have is a version number. If there is a URL, then the unique identifier is URL plus version number. So if I have version number 123 and no URL, I can't guarantee you that's the same as URL plus version number 123.
No. At least in my mind, the version is the only identifier. The URL is just out of convenience for a system to retrieve it.
Yep, I get that.
If you guys prefer to remove the URL, we can remove it. My thinking is that it's most convenient to have it, but.
Yeah, but the unique identifier is just the SymVerd number.
Yeah. Okay, so Amit, I think you can proceed this in this way.
Thanks, Andre.
Great, perfect. Let's go to the next step. So we have started a documentation around additional error reasons, proposals. Holger, do you want to give us some thoughts about this?
Didn't you you have discussed this already in a meeting I wasn't
yeah, but
taking part,
about,
right? So
Yeah, exactly. So you weren't in the meeting. I just want to get your perspective on this.
Yeah, so I mean, yeah. So
Go ahead.
The reason for doing that was that we have in several places now implementation now the fact that there is something, an error happening, and the only thing we can return is internal error. And we wanted to give the northbound system, or at least the logs, more information so that you actually can see what the problem was. For example, if a device is offline, then you cannot do a software update. So you will get an error back. Currently, it's internal error, which always looks like it's a problem in the device manager, but it actually is not. And that's why we defined several generic reasons which could be used, and then even some special reasons. For example, if you configure alarms, you can configure a wrong threshold value, and there's also no way to give you anything back to show you that the threshold was wrong. I mean, I do not really expect that a northbound system is really passing that information and doing something, but I think it would be much more easier for if any problem shows up later on. I mean, I can show you that, okay, the threshold was wrong. Otherwise, I will have no information. So somebody would tell me, you sent me back internal error. What was the reason? And without any log files, I have no clue. And this would be much easier if there would be better reasons to do it. This was the basic idea. So seeing the comments in the document, it looked to me like you are not very much in favor of the idea. So I also propose that I don't know, I didn't get the comment from you, Andrea, but it looks to me like gRPC allows you to return an error string in addition, which is just a free form of whatever. But this could also partly used then for logging and for communicating then. But I also got the feeling that you didn't like this. Which is fine, it's just a proposal, but
yeah. So the move to the gRPC errors instead of what we have in there, I would say totally not. The addition of a message, possibly, yes. The issue I have in having strings in places is that people put in whatever they want in the implementation, and this becomes non-standard, and everybody has to deal with like random stuff. So I'm totally fine in adding new enumerations with the information that you added down there. So like all of these other additional reasons, I'm totally fine with in adding them, no problem at all. What I do not want is something that is where like you guys can put in something and the next implementer of this one puts in something else, and then we have to go in and parse a string. No way. I want the API to be as clear as possible. So I'm totally fine having other reasons. So if you want to submit a change for adding these other reasons, please do. It's totally fine by me, but not a string. The string, because otherwise the implementation gets messy. It relies on the implementation itself.
Yeah, I mean, I get it, but really the intention was not to have something which gets passed, but it's just a node, an additional node to the error response you. So
yeah,
it's an additional node to the typed error response. Yeah.
So the issue there is that then it's the string that you put in there, it starts becoming things that get parsed by the systems, because as soon as you have something, you use it, no? So either we have all the rest of the information and people don't have to look at that string, and it's just for like human readability, which at that point I don't care. But if we don't have specified everything else, and that string becomes fundamental for a northbound system to act upon an error, then we're doing something wrong.
Yeah, but again, this was not the intention. Like it is written there, it was really just to be only informational and not intended to be evaluated by any system. So it's. But I know. I get it. If yeah.
I know.
No, I mean, this is fine. If I mean,
no, particularly.
Okay.
I mean,
Hi.
we saw this with reason, right? Where reason all of a sudden became this string that we're parsing and using in the tests.
Yeah, but at least the reason is an enumeration. And we know the existing possible values. And whenever you get an event, you don't care if it's from implementation X or implementation Z or implementation Y. You just get the event with the reason, and you don't have to look at the string and parse it. And maybe somebody did a capital S for a string, and somebody else did a lower
I
S for a
agree.
string.
I agree. But I mean, when we're looking at the tests, we're parsing the reason from volt-cuttle, right? And that becomes problems when those reasons change. I'm agreeing with you actually that it needs to be an enumeration. It can't be a string. And there is a risk anytime you put a string out there, even for human readability, someone starts using that, especially if that string is a differentiation. So when I look at the examples down below for the special reasons, it could be wrong threshold would be the event, but then threshold exceeds maximum is kind of the extended reason, if you will. If I read the document correctly, and someone's going to say, "Oh, I see the event is wrong threshold. That's enumeration, maybe." But then let me parse this extra data, and they're going to say, and they're going to use that somewhere.
Yeah. So I totally agree with David here. So out of all of this, my suggestion would be extend enumerations, extend the reason enumeration with as many reasons as you want. I don't care. Just put like all of them. Except
Okay.
just don't put adtran specific ones in there. They have to be somewhat reasonable reasons. But don't go with the string. The other thing that was done down here was that we wanted to add invalid startup configuration. I'm not really sure if we want to do that again, just because you're asking for you're doing an API, so you know the API that you're doing, and you get invalid config back. You know it's the invalid startup configuration.
No, this was fine to me. The problem was, for example, because there was we didn't have any enumeration for wrong threshold. We would then use invalid config for that, which for me isn't
I see.
the best solution. That's why I wanted to use invalid config only for. I mean, this was intended for startup config, so. I just wanted to make sure that not everybody's using invalid config everywhere when there's some problem, but just use a better one, a specific reason instead.
Okay. Yeah. No. Then I think if you add other reasons, you might want to leave this one to invalid config, or you can also add invalid startup config. Just leave them both. As I said, as soon as they are defined, and each of them is well documented to what it's supposed to be, I'm fine with them. I'm fine even having like invalid config and invalid startup config, as soon as they are documented properly. But
I think this is a good point. We have to work on the documentation as well.
Yeah, so that is the one question that I put out there, saying that should we announce our documentation on each of the APIs, saying that, okay, these are the errors that this API could return, and what are the specific scenarios under which error should be returned? Because if you don't have consistency in this across implementations of the device manager, then the not-bound systems would have a tough time, right? Because if they start returning different error codes for the same situation, right, then the not-bound systems will have a tough time handling it.
Yes, I would agree. So what I would suggest here is, so out of all this document, what I would do, I'm gonna go back here. So what I think we need to do is add additional reasons for the document in the enumeration. and properly document all the reasons with the according situation they are intended for. So in this
What
way,
does it mean we should? Sorry, go ahead.
No, go ahead. Go ahead.
Yeah, I was asking if we should just for every RPC define the possible error codes which could be returned and what they mean in that case, or is this too much?
That's one way to do it. The other way is that I think that the one reason is really self-explanatory. Sorry, mapped to like it's only used in a context, meaning that you don't use a reason for two different things in two different places. For example, let's take the invalid configuration one. If we say we don't use it for startup, so we have invalid startup config for that, and you give to me like some number in one API and another number in another API, and both of them are wrong, I could still use invalid configuration, and the documentation could say something is returned when the given argument is not suitable for the call, and no other existing reason can be used. For example, if you give me a wrong threshold, I should use wrong threshold, not invalid config. Does that make sense?
Yeah. So,
do we envision a set of compliance tests around this so that we can even synthetic errors,
Yes,
making sure
yes,
that,
we do.
that we can get the same error? So at some level, we should be guaranteeing the devices or different implementations provide the same error under certain circumstances based on those tests.
Yeah, David, we're working on that. So the idea is that you have an exemplar implementation on BBSIM. Out of those, we're already writing, thanks to Uwe and Torsten, Adatran, some tests. And I do have a job that currently runs 3 tests in Jenkins, but it's still a start, that is meant precisely for the reason.
Right.
You just
All right,
mentioned.
cool. So we'll get some consistency. You know, documentation would be good too, but we'll get some consistency from the testing.
Yeah. And there also an exemplar implementation with BBSIM that tells you effectively, shows you effectively what a reason is meant for.
So, Andre, I think that idea is also good, right? If we, instead of having one enum, the reason, which is used across multiple responses, and depending on the response, you choose, okay, for response 1, these 5 are valid. For response 2, these 6 are valid. And we document this, right? We could define individual reasons for each of the responses, and that would contain only the permissible enums for that response. So although the enum names will be repeated, but I think that should be cleaner, right? That will not cause any ambiguity.
Good point. What do others think about this?
Yeah, I like it, but it's quite
it's more work
for you, Amit. Yeah, I know.
Yeah.
But I mean, writing the documentation is also work. So if you introduce these new enumerations, perhaps there's no need for this kind of detailed documentation anymore.
I mean, yeah, I think both are needed. A pretty good documentation is always needed. And if we go down this route, there is really no chance that we get it wrong from the northbound perspective. Amit, does anybody recall if the concept of extension is there in protobuf? I have to be honest, and I don't recall that. Because if it's there, we could look at possibly consolidating the most common ones, which would be present in all of those, and adding just a few for each reply, which could be a nice middle ground. What I would like to avoid is like an explosion of enumeration, like 30 enums with like 4 values, 5 values each, and 3 of those are repeated for all 30.
Not sure about the extensions.
Okay. So
I think
well,
we can do a check on it and see
yeah,
as in how it goes, and then take a call how we should implement it. Either the
yeah,
documentation, define reason for RPC.
yeah, I would agree. So let's do that. I'll let you guys take a look at this and take a step forward in this direction and see if it can be inherited or not. But in any case, I think documentation and either one enum with many reasons or multiple enums is the right way to go, and it's the outcome of this one. Okay.
So just to conclude on that, so let me clarify here. So we are saying that we still use the reason field in the response messages, right? And not only the status returned by the RPC call, the error codes returned by the RPC call.
Yes.
Okay.
Okay. Good. Okay. Just a quick question, Raj. How much time do you need? Sorry, Sean. How much time do you need?
Sorry, I was on mute. Probably maybe, I don't know, 10 minutes, maybe 10, 15.
Okay, that's fine. That's fine then. I think we can get it. Let me just bump this up. Might skip the recover the stuff. Okay, so just what I was talking about before with David, just this 2 minutes from myself. We have included some initial tests in Jenkins. Again, as I said, it's 3 tests. It's not like incredibly big number of tests. It's failing for 2.6 because I have to cherry pick a patch. Leave it. I'll do it. It's already on Gerrit. I'll merge it before the release. And this one just runs 2 tests. The 3 tests, which is start, stop, and get a list of components. But as I said, it's a good start. And we have it in 2.6, and it's based on the version of the latest version. So it starts and stops, it gets the inventory data, and gets the configurable component. There are actually 3 more tests, which are logging tests for getting the loggable components and setting log levels and things like that. Unfortunately, BBSim does not have that implemented. There's a Jira ticket for it, but they are there. So as soon as BBSim implements that, we're going to go in and implement turn on the test. I know also that Amit is working on. There's a patch for BBSim. Link to create device events, and as soon as that gets merged, we will go ahead and look at having a test for these events. So that's also something that we're working on. Okay, that's all I had on the Jenkins job. I'll keep updating it and working with Thorsten and Uwe and the team at Radisys to work with this. Okay, I forgot who put this in. I put it in, but I kind of forgot the context. I think it was Holger. I mean, it was probably a discussion with you guys, but I kind of forgot the
This
context.
is something I think we discussed in the last call, but I've not made any further progress on
Oh,
this.
okay.
Let's keep it for now. Take it up in
Okay.
the next meeting.
Sounds good. Okay, then Sean, the floor is yours. What Sean plans to do is to propose an example implementation of the DMI that works on top of any white box OLT. So, Sean, go ahead. Do you want to share the screen?
Well, so basically, I initially just wanted to kind of introduce the proposal. So basically, we're planning on developing a device manager and an agent with a gRPC interface between them, and again based off of the the standard or definition of device manager that was proposed by DT and Amit. And so we have kind of a lead developer from Radisys who's on the call, Chandra. I'll let him kind of introduce the project and what kind of we're planning to do. And so with that, Chandra, do you want to present some slides on this?
Yeah, sure, Sean. Let me introduce myself. I am Chandrakant, working for Radisys. I am part of the broadband access technology. Yeah, I have basic understanding on the CORD, SEBA architecture and the owners. I would like to take a couple of minutes to run through the proposal wherein Radisys we want to contribute to the device management brigade, and I want to get your suggestions and inputs on the same. May I present my screen, Andrea, with your permission?
Yeah, please go ahead.
I hope you are able to see my screen shared.
Not really. Let me stop myself. Can you retry now?
Yeah, can you please let me know if you're able to see my screen?
Yeah, we can see it.
Okay. Okay, thanks a lot. So we would like to contribute to the Open Device Manager that implements the DMI interface talking to the NEM components, and the Open DM adapter that can talk to the device on the device native interface. As Sean mentioned, we are proposing to consider gRPC as the interface protocol between the Open Device Manager and the OpenDM agent. So we would like to contribute on this Open Device Manager, consuming the interface and translating the procedures towards the native device interface. And as I understand from the DMI, these are the areas that are being worked upon: the hardware, software management, events, and the metrics. So I just tried to put together on the gRPC. Like the gRPC is a high performance RPC framework which has built-in HTTP2 support, which eliminates issues such as head of line blocking and supports the bidirectional streaming and the authentication. And we have the auto generation of the buffer code for serialization and the retrieval, and the auto generation of server and client code. And we believe we can easily map the NEM procedures to the device native interface procedures, largely using the proto definitions. Yeah, coming to the details, first we would like to get started on proposing the gRPC protobuf based native device management interface between the OpenDM server and the agent, and define the protobuf based gRPC for hardware, software, and event metrics management to the progress that the DMI Brigade has made progress. And then contribution on the Open Device Manager, wherein we would like to contribute to the design, implementation, and the testing of the Open Device Manager, which is a microservice-based architecture and Golang-based implementation, and the implementation of the gRPC server on the DMI interface towards NEM and the client towards the device, and the required device context management, the configuration, UUID, inventory states, and the finite state machine, which is required to implement the features such as device software upgrades, and the events configuration from the northbound systems, especially thresholds, and the generation of the events alarms based on the thresholds, and reporting the metrics based on the sensor data from the device. And we are looking forward to contribute to the Open DM agent that sits on the device, gRPC server based implementation. And we plan to get started with the Open Network Linux ONL, and we would like to consume the standard Linux commands, the OpenLP APIs, in order to manage the events and the metrics. So I would like to take a break here, and maybe if you have any specific questions, we can discuss.
Would you characterize this proposal as essentially writing an EMS NMS above the DMI interface?
Sorry, please go ahead.
No, please.
I'm sorry, whoever's speaking is breaking up, at least for me.
Yeah, I don't hear anything besides music, but yeah. So the idea is to actually provide a device manager and the agent and the protobuf gRPC messaging between the two. So I mean the interface is as defined by the DMI manager, right?
Right. So the agent is what sits on the device, and that's already done, right? That's on the device. So this proposal seems to me to be writing a device manager, possibly an EMS, if not an NMS, on top of those APIs.
No.
Effectively not, David. If I understand it correctly, this is not actually present at the moment. The OpenDM agent on the right side to the bottom, that's not there.
How's that different from the DMI interface then?
Well, that is an implementation of the interface. So this is an hold on. The DMI interface is from the gRPC server that you see there in the middle to the NEM components. Right. And then there is kind of like we have, at least the way I understand it, kind of like the way we have an OpenOLT adapter and an OpenOLT agent. This is effectively the same thing. There is the DM agent, which is the one on the bottom, that communicates with a component that is the adapter that speaks the DMI interface northbound. And the idea is that you have multiple devices, but just one DMI component, which is the big blob there in the middle.
Okay, so the open DM agent at the bottom there, that's not something that sits on a device, or is something that sits on a device?
It sits on the device. It's the equivalent of the OpenOLT adapter agent, but for device management specifically.
So you want, I'm sorry, I'm just trying to understand this. So that you're looking at that open DM agent to say, look, here is the base agent you can implement on your device or tweak it for your device, and it'll speak the DMI interface northbound.
Well, it will speak the equivalent of that DMI interface northbound, but to the device itself, right? So basically, it would get the request from the NEMIC, I guess in this case, and then it would pass that request for information down to the open DM agent, or it would configure the thresholds for generating events or alarms on, say, temperature or some other threshold.
So, okay. So there's a couple different concepts here I'm still struggling with. So
yeah,
the open DM agent, the bottom box, that's going to reside like the other agents we have on the device, and it is an implementation of the DMI interface. That's going to speak to this middle microservice architecture, which is essentially an EMS for multiple instances of devices.
Well, no, but the gRPC, the OpenDMA agent basically gets the gRPC requests, right, on the physical device itself.
Yep.
And then uses the ONLP interfaces to go and execute the requests, right, on the physical device itself. Yeah.
Right. So that's just an implementation from my, if I understand correctly, that bottom box is just an implementation of the DMI interface server sitting on hardware. Correct?
Sorry to interrupt. So Sean, I'd like to ask the same question, but in a different way. So is the interface between the open DM agent down in the device and the box on top of it exactly the same as the DMI interface, or it could be similar to the DMI interface?
To my knowledge, it could be similar. Yeah, please go ahead, Sean.
Yeah, so the idea is, we want to keep it as similar as possible, I guess. I mean, there's all kinds of,
correct, but it's
an
not
interface to the KV store.
It has to be exactly the DMI interface, right?
Yeah, I'm confused. Why would we define a DMI interface if now we're going to say, oh, by the way, we're going to come to define yet another interface which is similar but not guaranteed to be the same as a DMI interface? Why not just the DMI interface?
Well, the idea is it's based on that, right? So it could be exactly the same.
It should be. It must be exactly the same. Otherwise, the DMI interface is pointless. Yeah. No, it must be the same. Otherwise, the DMI interface is not meeting what it's supposed to do.
But I mean, except for all this Kafka messaging, which is done by the DMI interface for metrics, events, and so on, this is only. I mean, it's depicted in a way that this is only happening on the northern side of the bigger box, whatever this. So it's north of the Open Device Manager. This is speaking Kafka, and so you have to add gRPCs for forwarding events from the agent to the device manager, and then the device manager is creating Kafka events out of these, right? So it cannot be the same interface.
Yeah. So basically,
no, wait.
Hang on a second.
Go ahead. Yep.
So imagine what is currently there right now for device manager, right? So there's a couple of implementations, I guess. One is Redfish based, right? So that there's a the gRPC interface exists in that model. Then there's a conversion to Redfish, and then there's a messaging that goes down to the white box OLT, and there's an agent for Redfish there, right? Or it could be a netconf southbound interface. So basically the same gRPC interface is northbound that comes into netcom. There's a conversion to netcom, and that goes down to the netcom device-based device management agent on the white box OLT. So what this is doing is saying, let's take gRPC and the defined gRPC northbound interface, and let's use that gRPC messaging to talk to a gRPC-based agent on the white box OLT. There's no conversion there, right?
Mm-hmm.
But this device manager is still talking to that agent on the white box OLT. It still needs to do all the Kafka alarm, event messaging, etc. Right? So it's still functionally doing all that same stuff, but the interface between that device manager and the agent is just PC based, but not Redfish, and it's not netcom.
So in a DMI implementation on top of Redfish, the assumption is the DMI implementation is off box, and then it talks Redfish to the box,
Mm-hmm.
and to a Redfish agent on the box, and then there's translation.
Uh-huh.
So in this scenario, wouldn't a Redfish implementation be wouldn't there be an OpenDM agent Redfish implementation that speaks DMI northbound, and then just on box the agent kind of does a talk to myself via Redfish protocol?
So yeah, in theory, in theory, you could do that, David. In practice, I've not seen it, and I think that having this way of doing it, you could effectively have the translation happen in just one object instead of having each device having to translate to the device manager interface. That's one thing. The other one is that, if I understand it correctly, that interface down there, the device management agent to this blob, which is the Open Device Manager, that can be, as we have for BBSIM, basically a one-to-one, one device on the device management interface. And it could be that. And in theory, if you just have one device, you could have NEM talking to that piece.
I guess my issue, if we're gonna require an agent on the device, why not just require the agent on the device to speak DMI up northbound?
I'm fine with that. It's totally okay. The thing is that I don't want to require that object to store information that on the device, to store information such as the Kafka bus addresses, the NEM address, and other things that are really related just to the management side of things that the device shouldn't care about. So I'm fine speaking DMI, actually should be, but there are things within DMI that are thought for a set of devices.
There are things in the DMI that capture. Can you give an example of that?
Oh, start managing device, stop managing device. That's just, could be multiple. It could be one, not could be multiple. And also the whole Kafka side of things, we decided that we need that because the operator needs them, but it could not be on the device. Actually, I would actually prefer it not to be on the device, because otherwise you would overload the device itself.
I've got to go back and look at, I guess, the definition of the DMI interface. Because to me, the DMI interface is, at least was originally in my mind thought to be, this is the interface that the device speaks up for to make it manageable. To make it manageable. And then there's the manager that would sit on top of multiple devices using DMI to talk to the device, and then doing whatever a network management, EMS management wants to do. If the DMI device is beyond that, then I think there needs to be a separation between and maybe this is what we're trying to qualify here, is the DMI interface should be the interface that makes the device manageable, and if there's a higher level manager, that's the one that has those bits that aren't specific to a single device.
So the way we started this was precisely to have a capability of a device or multiple devices at the same time to be exposed through the interface. So it does not mean that it has to sit on the box. We didn't define it as sitting on the box or sitting outside. And in the way Adtran, for example, implemented is that they have one object speaking the DMI interface that then talks netconf to the multiple devices. And I'm perfectly fine with that because they already had a component sitting on the device that spoke that language, which is the netconf models they have. And they didn't want to like write another component that speaks to the device's APIs. They just said it's better for us to do a one component that speaks DMI on the northbound, and then we deal with our netconf southbound interface. And effectively here is the same. The important part for the NEM is this API here, the gRPC to gRPC server to device management interface, that northbound there, that's the important part for the NEM. Whether that piece talks directly to the device or talks to an element that then talks to the device with some other gibberish language, I don't particularly care.
Right, we've just recreated the EMS-NMS problem that has been plaguing us for 20 years. Right, some of the things are multiplexers, some of them are one-to-one. Right, if you have multiple vendors in your environment, you know this DMI implementation is one-to-one to a device. This DMI implementation is one-to-N to a device, and something has to sit above it and organize it. I think what was just specified is
actually the way I see it is that everybody should do it like one component that speaks DMI and exposes the Kafka and then talks to whatever language they want to their device.
So now if I have multiple vendors, I have multiple instances of this, and
yeah, and everybody speaks the same exact DMI interface and talks to
but now add device, right, but now add device means, oh, if I want to add vendor one device, I have to call this DMI instance. If I want to add another vendor's device, I've got to do this one, and each vendor implementation is going to have its own management system, which is keeping inventory for its devices, which may or may not be filtered up. It's again, this is the standard NMS problem, right? And until the whole point of OpenFlow, for example, going here was every device speaks OpenFlow, and so everything above that is identical, right? And that was what my thoughts around the DMI was. Every device speaks DMI, and so everything above that's identical. What we just said is no, that's not the case.
Well, no,
Sorry, David, the problem is exactly the same as the OpenOLT adapter and the OpenOLT agent, right?
Okay, but you got to also understand that the OpenOLT agent came to play. I'm like, why are we doing this? Because what the OpenOLT API should have been what the iAdapter API should have been, right? So I wasn't particularly thrilled with that solution either. But
yeah, but in that case,
protocol.
In that case, we're pushing stuff into the box, right? But that is the idea that we came out from, that we want to pull out software from the box, not push it back into the box.
Right. The device should speak a common northbound protocol. Everything on top of that should be generic.
So the difficulty that we encountered is that it's a lot easier, as Amit said, it's a lot easier to push stuff out of the box and do conversions out of the box than do it on the box. And I'll let Holger intervene if I'm saying something wrong. But if I would have asked Adtran to go and work on their component and touch their software that is running on their boxes that speaks netconf at the moment and extend it with the DMI interface, I'm gonna go get a no. Instead,
I get that. I absolutely get that. But again, that was the whole point of the OpenOLT agent, right? Oh, by the way, we're going to push this agent down to the box so that it speaks a common protocol northbound, and we can treat all these boxes the same. So if I can push it,
because the OpenOLT agent.
Go ahead.
No, because the OpenOLT agent only works on the edge core stuff. Adtran has its own agent. Nokia has its own agent.
Yeah. Radisys will. Then it's not an OpenOLT. then it's not an open OLT agent. It's a vendor-specific edge core agent. If it only works in one box,
exactly.
it's not open.
You want
If it only works,
adapter to speak northbound. You don't care what runs on the hardware. So same thing with device management.
So again, if it only works in one vendor, it's not an open agent. It's a vendor agent.
Well,
if we want to say we're going to go, if we want to say each vendor can speak whatever it wants northbound, so it's not a common protocol. So it's not like OpenFlow. It's not, we're not implementing a standard. We're going to say, we're going to create an EMS with adapters for each vendor. That's, again, what's been going on for years. And by the way, some vendors have their own EMS to manage all their devices. So the common EMS will speak to the vendor EMS, and that vendor EMS may be a multiplexer. Again, we can do that, but again, that's what's been going on for years in this market. I disagree with that because I think we're just recreating the same problem. We're not actually solving a problem. I would also argue that we're almost going against ONF with they're trying to create common manageability, OpenFlow P4, common manageability for devices, because we're perpetuating essentially vendor specific interfaces. And I'm a vendor.
Right. No, but there is a standard API, right? That's the device management API that talks northbound to whatever you're.
Right, but what we're saying, this would be the equivalent of writing OpenFlow adapters that are completely off box, and then speaks SNMP, TL1, whatever to the box.
Well, do you care?
This is exactly what's been going on in this industry for 30 years.
Right, but
the problem is we're not pushing the solution forward. We're recreating the same solutions that have always existed. Do I agree with that? I have a problem with that, because I thought part of what ONF's charter was to do was to, along the lines of OpenFlow, say, look, we're trying to create common manageability for devices on the device, right? Versus off, and I've also, so it doesn't seem like we're pushing ONF's mission forward, and it also feels like we're going to run into all the problems we've had around device management that we've been dealing with for 30 years. And if that's the only way we can do it, okay, but this is going to be a beast that goes on and lives on and grows for the next 20 years, right? This is not nice solving a single solution. This needs to become a separate project, because now it is much bigger than what it was originally called. This isn't Potter Volta. This is something else. This is the whole device management project, how to build EMSs.
So this was never intended to be a part of Volta. It was always decided that this was aside from it. It's just that a complete solution needs some sort of management. And to be honest, I don't feel as strongly as you do with the fact that this needs to be on the device, because the translation needs to happen, and whether it happens on the box or it happens off the box and you don't see it, from a northbound perspective, there is really no difference. The important part is that at one point, in one place, there needs to be a common interface. That common interface is what we are putting together. And whether it is spoken by the box, and I would be perfectly happy with that, I would actually be very happy, or it is spoken by a system that then talk to the boxes because of its existing hardware already deployed in the field that has that APIs, because we cannot touch the system itself, because it would be too complicated to touch the system itself. We have seen that reinventing the wheel and asking everybody to go and implement things on hardware is not going to work. So given all the things all the experience we have had, what I'm pushing, what my idea is, and you're also over time, so I think we have to close this, and we might reopen the discussion, and we might also take it offline. But what my idea is that if either the device or a component speaks the common interface that I care about, I don't particularly care what is that thing that speaks to me. I just issue a command, and that command gets done.
We are over time. I'd like to take it offline. Again, one guy's opinion, I suppose, but let's just take it offline.
Okay. Sorry, we hijacked the presentation. Let's take the discussion offline. I have another
Yes,
meeting
right.
that I have to attend, and sorry for that. So let me schedule a call the first time it's possible in January. In the meantime, we can also start a thread or personal discussions and have a sync up on that, and come up with an agreement here. In all honesty, we have put a protobuf out. I'm going to close here, but we have put a protobuf out. How people implement it, it's not really something that we can decide. But again, let's take it offline. And sorry for going over, and thanks a lot for staying.
Yeah, and I mean, there's always been this separate management path to give you a complete system, right? A complete manageable system. I mean, there's the open flow path, and then there's the other path. But, okay.
Yeah, thanks a lot, everyone, on the inputs and suggestions.
Yeah, so we'll follow up on this one.
Yeah, absolutely. And let me just take a minute more of your time to wish everybody a happy holiday break and a happy New Year's Eve. I hope everybody stays healthy and safe, and their families too, and you get to spend some quality time with the people that you care about within your life. That's the most important thing, and I really do wish all of you the best for these upcoming days of holiday and relaxation. So I hope the best for everybody.
Thank you. Appreciate that.
Thank you.
Same.
Thanks.
Have a nice holiday.
Repeat the issue. Yeah. Thanks. Bye.
Good try.
Bye now.
Cheers. Bye-bye.
Bye. See you next year.
See you next
Thanks
year.
all.
Bye-bye.
Bye.